So let's start. I think everything seems to be working now. Okay. So in the previous class, what we were doing, I think we had done what was the last topic? Forgot. What was the last topic that we are doing? Are anyone forgotten the last topic?
Sir, completed logic gates.
That means that means what? That means that we have done modern physics, right?
Yes, sir.
So modern physics is done, and as promised, today we would move on to the next topic. Again, a topic which is not very big, and we will definitely have questions coming from this topic. The name of the topic is alternating current or AC or alternating circuits, whatever you call it. Any idea about what this topic is? Any idea what this is? Have you heard about AC, alternating current, alternating circuits? Have you heard about this?
Alternate current, direct current, alternate, which is connected parallel, which moves in both direction, forward and backward.
Forward and backward. Okay.
Electrons which move forward and backward.
Electrons which move forward and backward. Okay. Instead of calling it forward and backward, can you call it by some other name? Instead of calling it forward and backward, can we call it by some other name? Think about something which is which looks better or which sounds better.
Alternative way.
Alternative way. Okay. Alternative way sounds better. Can we have more clarification? Can we give it more meaning instead of calling it alternative? So just to make more sense out of this, I hope you can see this, right? You can see what on your screen, right? I am not able to log in by the other ID. So do you see on your screen what you see?
Constant DC, periodic DC, direct current.
Right. So basically, if you want to understand the difference between AC current and DC current, now here in the first case number 1, what do you see? This current is remaining constant with time. Yes or no?
Yes, sir.
This current, this type of current or this type of voltage will be known as DC current or DC voltage. Do we understand this?
Yes, sir.
If I look at case number 2, and you will have to draw these two cases. If I look at case number 2, here also the current is not constant. Here the current is not constant. Here the current is varying. Here the current is varying. But the direction of the current is constant. Do you understand the meaning of the term direction of the current is constant? That means the current always flows in the same direction.
Constant.
The current always flows in the same direction. It is going from A to B like this. It will always keep on going from A to B like this. It will never come from B to A unless and until we change the circuit. Such current which remains constant with time, it may change its value, as you can see in equation number 2. In case number 2, the current is changing its value, but it is not changing its direction. Such currents or such voltages are known as DC current or DC voltage. Do we understand this?
Yes, sir.
This is what you will draw. You will write what is there in the yellow, and then you will draw the two diagrams, because there can be a question that comes where they give you diagram and they ask you which one is AC and which one is DC. Do we understand this?
Yes, sir.
Draw it. Fatafat. This is not in your sheet. Have you got the sheet for AC?
Yes, sir.
Just now you were distributing that only? right? So this is what DC is all about. DC or direct current or direct voltage, DC voltage. If the voltage does not change its direction, it may change its magnitude. That voltage or that current is known as DC voltage or a DC current. I'll wait for a minute. I'm having problems in the other ID. Problem is probably because of my internet connection. I don't know what's wrong with my internet connection. Everything looks good. Okay, let me try this. Have you noted this on bacha?
Yes, sir.
Okay. Now, when does what? When does it become an AC? When does it become an AC? It becomes alternating. Now, can anyone tell me when it becomes alternating? Yes, bacha. When does the current or voltage become alternating in nature? Now,
When it moves periodic.
yes, when it changes its direction periodically, and why this entire thing is moving, when it changes, okay, maybe something wrong. When it changes its direction periodically, why it is moving? I don't understand. When it changes its direction periodically, that means sometimes it is coming from A to B. After some time, it will come from B to A. Then it will again go from A to B. Then the current or voltage become alternating. Do we understand this?
Yes,
Do we
sir.
understand this, bacha? Now look at example number 3 or graph number 3. Here the current is changing its magnitude, but it is not changing its direction, and therefore it is still DC. It is a variable DC. Do we understand this? Can I have some reason that we understand this? Look at equation number or graph number 4. Here the current is going jig, 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 jig like this. What you can see, sometimes it is positive and sometimes it is negative. Do we see this?
Yes, sir.
Positive and negative here refers to the direction. If I call this direction as positive, this direction as positive, this direction becomes negative. Do we understand this? Do
Yes,
we
sir.
understand this? In case number 5, also sometimes it is positive, then it is negative, then it is positive, then it is negative. Since it is changing its direction, which is given by positive and negative, this current or this voltage becomes AC, alternating current or alternating voltage. Do we understand this?
Yes, sir. Understood.
Please draw the diagram. Please draw the diagram. Please draw the diagram. And again, we'll be discussing those points which I think can come directly in your examination hall. Now remember, this is not the part of sheet that I've given you. I've given you a more concise sheet. This was too big for you to give. And then you would have got confused. That's why I'm not given you this. Have you noted this down? Shall I move ahead in life and in time?
Completed, sir.
Completed, sir. Well done, sir. Then, in this chapter, we will be coming across two terms, and I have seen many questions coming on those two terms, and that is why it is prudent that I tell you that one term is known as the average value, and the other term is known as the root mean square value. Now, what do you mean by average value? Now, this is how we define the average of any function, and it looks very big. So what I'm gonna do is I'm gonna cut short this, and I'm just going to show you that function that gives us the average value. And you might seem a lot puzzled, you might look puzzled, but beta, this is how average function is defined in maths, and I can't help it. This is how an average function is defined in maths. It's a concept of it's the concept of maths. F, as you can see here, is the function. Do we understand this? F is the function. Do we understand this?
Yes, sir.
This symbol, the square symbol or whatever you call it, this symbol stands for the average value. Do we understand this?
Yes, sir.
Now, if I want to find the average with time, remember, if I want to find the average with time, I multiply it by dt and I find the integration of this. Do we understand this?
Yes, sir.
And then I divide it by the time itself. This is how I find the average value of any function with time. Average value of any function with time. Do we understand this?
Yes, sir.
Have you noted it down, bacha? Have you noted it down, bacha? You have to remember this, because a straightforward question can come from this. Then please, you will have to mark it correctly.
Sir,
Yes, bacha.
repeat it once, sir.
You have to remember this formula, beta. Integral of f dt divided by dt, divided by time. You have to remember this formula. This is the formula for average value of a function. This is a math formula. There is nothing that you can understand here. You will have to remember this formula. Can you remember this for me? It's a maths ka formula, beta. You'll have to see this formula, because there might be a question that comes on this formula straight away. So you'll have to remember this. Can you remember this for me?
Yes, sir.
Is there anything that you want to understand in this formula? Because all these are maths term. Integration is a maths term. F is the function. Dt small time divided by the total time. T1 is the lower limit. T2 is the upper limit. Do we know this?
1 minute, sir.
Please note it down. Have you noted it down, bacha?
Yes, sir. Completed, sir.
Okay. Okay. So this is the maths ka formula. We have seen the maths ka formula. Yes or no, bacha?
Yes, sir.
Now this, you might be knowing this, that this thing that I have drawn here, oops, too much I have drawn. I'll just take this thing. In maths, it refers to the area of the graph. Do we know this? This is the area of the graph. So instead of writing it in this form, I can write it like this. F की average value will be area under the graph divided by total time. Do we understand this?
Yes, sir.
I'm not hearing you, bacha. Do we understand this?
Yes, sir.
Area divided by time. So a question might come to you. This is what they probably will not give you question on integration. They will give you the question with a graph, with a diagram. Can you solve it then for the average value? Yes or no?
Yes, sir.
Please note it down, sir.
Sir,
Please
have
note
you
it.
sent this sheet, sir?
No, sir, this sheet is not there with you, sir. So you have to note everything down.
Okay, sir.
The other sheet is there with you. It does not have these things. I thought that these things should be there. I could not add them in the sheet. So that's why this one. Got it? I can't send you so much of material that you cannot study. Yes or no? Because it is just going to create confusion in your head. And I don't want a confused head. Return the file, return the formula that I gave you. Do it fast. I don't have the time of the entire universe.
Completed, sir.
Completed, sir. Then, sir, you will put this formula, sir, in this question, sir, and we'll get. This is the type of question that will come in your examination hall. Here I have seen, we have a graph between current. You understand current? Current is the function between current and time. Do we understand this? And you have to find the
Yes, sir.
average value of current from 0 to 2 seconds. It could be a triangular graph. It could be a rectangular graph. Doesn't matter. You know what to do. Do you know what to do or not? There was a very famous song when I was of your age. I remember in 12th standard, there was a movie that came. The name of the movie was Rangila. Jackie, Amir, Urmila, Rangila. That Rangila movie had a song, Kya kare, kya na kare. Kaisi mushkil hai. What to do, what not to do. So I hope you know what to do. You know what to do in this question?
We have to find average value of current.
And how will you find it?
We have to find the triangle area by
And then divide it by?
time.
Your time has already started, bacha. And I'm waiting for the answer.
Area of triangle is 10 and time is 2 seconds.
Yes. So what is the final answer?
5.
And the final answer has to be 5. All of us understand this. Can I have some reason that we understand this?
Yes, sir.
Yes, sir. So, sir, it is my duty, sir, to show you the answer, sir. And do we understand how we have done this? How we have found out the area here in the first case? Yes or no? That is coming as 10 ampere second. We divide it by the time and the answer is 5 ampere. Do we understand this, bacha? Raise hands will give me more confidence that we are on the same page and we are in the same class. Your what your something wrong. I can't see your hands. So this internet is really troubling me a lot, but thank God I have got mobile connection and that's how life goes on. Life has to go on. The show must go on. Can't see your raise hand because I just can't change my settings over here. We understand this? Yes or no? We understand this? Yes, sir. I'm still not hearing your voice, sir. Your voice is the only connection between you and me, sir. There is no
Yes,
verbal,
sir.
there is no visual connection because I'm not able to make that thing work. And if I run both the things from my mobile connection, I will have lag in between. So I just can't do that. So we
Yes,
understand
sir.
this. I hope you
Yes,
understand
sir.
this, and we will move further ahead. These are the two things that you must remember because a direct question will come, and then don't calculate it. You should know this. The average value of a sine function or a cosine function, sine or cos, is 0 in a complete cycle. Is 0 in a complete cycle. If current is I sine omega t or I cos omega t or voltage is V cos omega t or V sine omega t, the average value in one time period is 0. Do you understand what is time period?
Yes, sir.
Average value of a sine function or a cosine function is 0. But if you have the square of the sine function, sine squared or cos squared, the average value of that thing is half. So if I find the average of squared function over time, the value will be half. Do we understand this? The average value will be half. You'll have
Yes,
to
sir.
remember this because there could be a question. There could be a question where they ask you this. So I hope you can work this out. You have a minute to win it. A minute to win it. A minute to win it. Can you win it for us? Have you done this?
30 seconds, sir.
Okay, 30 seconds. Given.
Completed, sir.
Completed, sir?
Yes, sir.
Then, sir, there is one more thing that you have to understand, sir, and this is this thing, sir. Root mean square value. Have you heard this term, root mean square? RMS.
Yes, sir.
You must have read it in thermodynamics, which is our next topic. And we'll be starting with the same thing, KTG, kinetic theory of gases. RMS, root mean square. Do we know this root mean square? This is the square root of mean of square of something. Do we understand this?
Yes,
So
sir.
first what I do is I square the function. First what I do is I square the function. You can see the square here, yes or no?
Yes, sir.
First I square the function. Then the next thing I do is in blue. I find the mean. By mean I mean the average. Do we understand this?
Yes, sir.
Then this formula that you see here is the mean. Yes or no?
Yes, sir.
The blue one. Blue one is the mean. Then what is the last thing I do? That is my pink. I find the square root of this. Do you see the square root here? Yes or no?
Yes, sir.
So that is what I mean by root mean
Squaring
square value.
value.
First I square, then I mean, then I take root. Is the formula looking good now?
Yes, sir.
Yes, sir. So if you understood shall I make the formula big or you can write it on your own?
Completed, sir.
Well done, sir. If you have completed the diagram, then you must also write these values for sine. What is the RMS value? Remember, RMS value is always taken in one time period or one cycle. We have written the average value of the sine function. I hope you can see this. If I find the average value of sine omega t over one cycle, it will be 0. But when I find the average of the square, it is 1 by 2. If I take the root of that, it becomes 1 by root 2, and therefore I have this formula for IRMS, IM divided by root 2. Do we understand how we have got this formula?
Value of current is 1 by root 2 times of maximum.
Yes. And that is what you should never forget in your entire life. Will you remember this? Will you remember this, bacha? Yes or no?
Yes, sir.
Okay, sir. Then, have you noted this down?
Completed, sir.
Then you must also remember one more thing. They might ask you a straightforward question. What is the RMS value in half cycle? Half cycle. Half cycle. Oops. Using a. What is the RMS value for half cycle? Whether it's full cycle or the half cycle, The both
are
the
same.
value are same. You must remember this and don't forget it in your entire life. Can you do that for me?
Yes, sir.
Redo it.
Completed, sir.
Completed, sir. Then this is a table, sir, which I am going to show you, sir. Now this is from your sheet, and this comes to you right away. Do you see this, bacha? There are three types of currents given. The first is I is equal to I naught. They have not used I, they have used X. The average value in one cycle is 0. The peak value is X naught. The RMS value is X naught by root 2. Angular frequency or angular velocity is omega. Do we all know these terms?
Yes, sir.
Similarly, if the function is like this, then the peak value is X naught by 2. Remember that, not X naught. The RMS value is X naught by 2 root 2. And the frequency of this thing is 2 omega. Why it is 2 omega? Because this is sine 2 omega by 2. Do we understand this?
Yes, sir.
That is why the answer is this. If the function is given to you in this form, you'll have to remember these values, because in the examination hall, you will not get enough time to calculate it. So you will have to remember this. Can you remember this for me?
Yes, sir.
Please note it down so that I can move further ahead in life. You have to note it down because a straight away question will come. Then please don't become Gajnis, because that will not serve any purpose. Ghazni only looks good in a movie. It does not look good anywhere else, especially not in your profession. I'll give you a minute. I've already given you a minute to note this down. This is from your sheet.
It is in the sheet, na, sir.
It is in the sheet, na sir, but you have to remember it, na sir.
Okay, sir.
Okay, sir. So just remember this, because you will not be able to calculate this in the examination hall. Shall I move further ahead?
Yes, sir.
Yes, sir. No, sir. Then, sir. Important point, sir. Again from your sheet, sir. Straightforward question will come from here, sir. If there are n number of magnetic poles, now remember this AC is generated, this AC voltage is generated in a AC generator. You might have seen or read about this AC generator in your class 10. Remember that, class 10 AC generator? Now this AC generator
sir.
works on the principle of electromagnetic induction. We have a current carrying coil moving inside a magnetic field. Yes or no?
Yes, sir.
Now this magnetic field may not be a simple magnet north and south. It may have many poles. Do we understand this? If there are
Yes,
p
sir.
number of poles, then what is the frequency of AC produced? Question has come previously. So remember this. Frequency of the AC produced will be Np by 2, where N is the frequency of rotation of the coil, the armature. The coil is known as the armature. Remember this formula. You should not forget it. Can you remember this formula, Np by 2?
Sir, armature.
Armature is nothing but the coil that moves, current carrying coil that is moving. Okay.
Oh, okay.
Current carrying coil is moving in a magnetic field. That current carrying coil is the armature. We understand this?
Yes, sir.
Please note it down. I will discuss all the points. You'll note down point number 1. AC is more dangerous than DC because the peak value is root 2 times. Do we understand this?
Yes, sir.
Advantages of AC over DC. All these are theoretical concepts. AC is cheaper. Straight away question will come. It can be easily converted into DC by rectifier. We have seen it in a previous chapter. Yes or no?
Yes, sir.
It can be controlled very easily. It can be transmitted. It can be stepped up or stepped down. You have seen transformer right in front of your house. Yes or no?
Yes, sir.
Again, what are the disadvantages? AC cannot be used in charging of battery. My laptop right now, I just switched the charging on, it does not charge from AC. There is a small device
Yes,
which
sir, we
converts
have
AC
to
into DC. Everything,
DC.
your mobile, it does not work on AC, it works on DC. Got this? It
Yes,
cannot
sir.
be used for electrolysis or electropainting. Again, straightforward question will come. If nothing is mentioned, and remember this is very thing, if printed in AC circuits on electrical appliances, any given or known values are assumed to be RMS. So if I say AC voltage is 50 volts, which value am I talking about? I'm not talking about the peak value. I am talking about the
RMS.
RMS value. Whenever we talk about AC, we always talk about RMS value.
RMS.
India, the value of AC that we use is 220 volt. It is not 220 volt. The RMS value is 220 volt. Do we understand this?
Yes, sir.
Frequency is 50 hertz in America, 60 hertz and 110 volts. I'll give you a minute to capture this entire thing in your head.
Adura.
Return this, bacha.
Yes, sir.
Okay, sir. Again, staying with your sheet. Most of the AC voltage or current that we are going to encounter will be sinusoidal. What do you mean by sinusoidal? They will be in the form of sine or the cosine wave. Do we understand this?
Yes, sir.
This you can see is the sine wave. Do you understand this?
Yes, sir. Sine wave.
This is the time period or phase. Here it is 0, then it is pi by 2, and then it is pi, then it is 3 pi by 2 here and 2 pi. Do we all understand this? Yes or no? Please raise your hands.
Yes, sir.
In one cycle, this is one cycle from here to here. Do we understand this?
Yes, sir.
In one cycle, it will become 0 2 times. Yes or no?
Yes, sir. 2 times.
It will
5
become
by 2.
maximum 2 times. One time maximum in the higher side, positive side, one time maximum in the lower side. Yes or no?
Yes, sir.
Direction will change 2 times. Yes or no?
Yes, sir.
For 50 hertz, this will be 100, this will be 100, and this will be 100. Straight away question will come. Please don't forget this. Now this bulb that I see, that is burning here, that is lighting up the skies here. Do you know, in 1 second, India is 50 hertz. It switches off 100 times. Do we understand this?
Yes, sir.
But it happens so quickly that we are not able to
See
visualize it. It looks like it is continuously giving us light, but is that the case? Is it continuously giving us light? No, it is switching off 100 times. Do we understand this?
Yes, sir.
Yes, sir. No, sir. You will have to remember this, sir. I hope you understand this as well. A phase difference of 2 pi. You understand the phase difference? Difference in angle is phase difference. A phase difference of 2 pi is equal to a time difference of t, capital T. Do we understand this?
Yes, sir.
X naught is the peak. From one peak, upper wala peak, to lower wala peak, the distance is 2x naught. Do we understand this?
Yes, sir.
You have 1 minute to draw this graph and write this. And do not trust your sheet. You may lose your sheet. You may forget what was there in your sheet, but you write with your own hands. Karma, you will have to do your karma, bacha. Lord Krishna has very definitely spoken about karma. You do your karma and leave the rest to me, and I shall take care of the rest. But if you don't do your karma, nothing happens. Yes or no? Yes or no?
Yes, sir.
Do your karma. Your karma right now is to note everything down. Have you done your
Sir.
karma?
You are noting, sir.
Noting. Note it. Shall I move ahead in life? Or shall I stop time here? Or any one of us is noting it down?
1 minute, sir. Completed, sir.
Completed, sir. Then, sir, we move on to the next thing, sir. And again, this is nothing new. Just telling you a difference in angle with difference in time. From 0 to pi by 2, the difference in angle is pi by 2. Do we understand this?
Yes, sir.
2 pi corresponds to t. So pi by 2 will correspond to t by 4. Do we understand this?
Yes, sir.
Then it is on the same line from 0 to x naught by 2. X naught by 2 will happen at pi by 6. The phase difference is pi by 6. The time difference will be t by 12. Do we understand this?
Yes, sir.
From plus x naught to minus x naught, plus x naught happens at pi by 2, minus x naught happens at 3 pi by 2. We have seen it in the diagram, yes or no?
Yes, sir.
The phase difference is pi. Do we understand this?
Yes, sir.
And the time difference is t by 2. The simple maths. I hope you understand this. Can I have some what? Show of hands, show of strength. Okay. Note it down. If you don't want to note it down, I can move ahead. If you understood this, I can move ahead. Have you understood this?
Sir.
Then again, I come to the remaining 3 points. Very important point that you must understand. Remember, the average value of AC voltage or AC current over one cycle is 0. Yes or no?
Yes,
Yes
sir.
or no? Okay. Now, when I am talking about AC in India is 220 volts, which value am I talking about? Which value am I talking about? When I say AC in India is 220 volts. See, you have become Gajini and that is not good. Just told you 2 minutes, 5 minutes back. Now, not a good sign. If you all are Gajnis like this, I'll never come to you when you become doctors. Because you in 5 minutes you will forget what was my
Sir,
bimari.
your voice is not clear, sir.
Yes?
So your voice is not clear, sir.
I'm asking you, when I say the voltage in India is 220 volts, which value am I talking
RMS.
about? Yes, RMS values that we're talking about. Now, if we try to measure the value of this voltage, now remember this voltage is continuously changing, yes or no?
Yes, sir.
We'll not be able to get any value if I use a simple
It is
device.
changing.
If I use a simple emitter, which I use in DC circuit, it will not give me any value because it will give me 0. Yes
It
or
is
no?
completely changing. Yes, sir.
It is continuously changing, it will give me 0. So to measure these AC voltages or AC current, we have a different device which is based on the heating effect of current. Now this device, which is based on the heating effect of current, remember that it will work both for AC and for DC.
Yes, sir.
But a simple DC emitter will not work on AC. Do we understand this?
Sir?
A simple DC emitter will not work on AC, but it will always show you 0. We understand this.
Yes, sir.
Now, this heating device, they measure the heat of DC or they measure the heat of AC. Do we understand this?
Yes, sir.
When they measure the heat of AC, they will give you the value of I square. When they measure the value of DC, they will give you the value of I square RMS.
RMS.
And we take the root of that. And therefore, whatever device tells me about AC is the RMS value. Do we understand this?
Yes, sir.
And that is what you will write.
Yes, sir. DC will not give the RMS value.
A simple DC emitter does not work on AC. Do we remember this?
Yes, sir.
A simple DC emitter does not work on AC because it shows you
0.
0. To measure AC, we use the heating effect. We use the heating effect.
Heating effect of current.
Such devices are known as hot wire instrument because they are based on heat. Such devices are known as hot wire instrument. So if it is emitter, it will be known as hot wire emitter. If it is voltmeter, it will be known as
Hot wire
hot
emitter.
wire voltmeter.
Emi-
Okay. Now this hot wire emitter or voltmeter will measure the RMS squared. You can take the root of that, and hence you will get the RMS value. Do you understand the entire premise now?
Yes, sir.
Yes, sir, or no, sir? Shall I move on, sir?
Yes, sir.
Okay, sir. Let me see. What should I start off with? Okay, we'll start off with this and then I will try to make some sense. Now, we have seen in DC that there are three components in a DC circuit. We are not talking about battery, I am not talking about switches. I am talking about the three components, and the three components that we already know of a DC circuit as are R. Do we remember this R? R standing for resistance, yes or no?
Yes, sir. Resistance.
Do we remember this C?
C.
Yes, C.
Speed of light.
Huh? Yeah. Resistance, we are talking about resistance. Why you are getting into speed of light? Yeah.
Capacitance.
Yes. Capacitance. What about L?
It is the length.
Beta, your 12th standard is finishing. And you are telling me in AC, L will stand for length. What should I do? Shall I hang myself from the ceiling? You don't know.
Inductance.
You don't know what is L. No?
Inductance.
Yes. L stands for inductance. Beta, you are at the end of your board exams are coming, right? Or your board
Yes,
exams are
sir.
already over. If you tell me L stands for length of the body, I will hang myself from somewhere, the most appropriate place that I find. Can't do that. Just can't do that. Some things are inacceptable. If you tell me, sir, I don't know ABCD, well, I'll say, well, what do? You just don't know it. Probably you're in the long class. So we do know L is inductance, yes or no?
Yes, sir.
God is still there. And God is showering us with all his mercy. Anyways, okay. R stands for resistance, L stands for inductance, and C stands for capacitance. These are the three circuits that we are going to talk about. Now, the difference between AC and DC, as we have seen that AC changes its direction, DC does not change its direction. Now, because of this change in direction, we can think it that way, that something else also happens. And what that something else that is happening is phase difference. Phase difference between voltage and current. Now, what do you mean by phase difference between voltage and current? Now, if you don't know this, I can understand this. But if you don't know what is L, I just can't make sense. Anyways, any idea what do you mean by phase difference? If you don't have any idea, it's okay. But do you have any idea what do you mean by a phase difference? No. Yes or no?
No.
It's a
No,
binary
sir.
thing. Either it's 0 or 1. 0 is no, 1 is yes. Yes. 0 or 1?
No,
0. So what do you mean by phase difference? Let me write an equation. V is equal to V naught sine omega t. Now let us try to understand what it could mean for us now. What does this V mean? This V means the instantaneous value of voltage. You understand the meaning of instantaneous? At any moment. Do we understand this? What is the value of voltage now? What is the value of current now? What is your position now? Instantaneous value. Do we know this? Instantaneous means right at this point, right at this instant, right at this time. Do we understand this? Please speak loudly. I
Sir.
can't hear you, bacha. Okay.
Yes, sir.
Okay, good. What do you think means what do you understand by V naught? We have already discussed this, so don't become Gajinis. What do you mean by V naught? It will stand for maximum value of voltage. Yes or no? Vm or V naught. It will stand for the maximum value of voltage. Do you understand this?
Yes, sir.
Okay, sir. Then this sine is your simple wave, your sine wave or your cos wave. It's a trigonometric function. Yes or no?
Yes, sir.
Well done, sir. Now we let us come to this omega. What does this omega stand for? And I hope everyone is writing and not looking at the screen. Right? This is not the movie that is going on. It's a class.
We are
Don't look
writing,
at the
sir.
screen. Yes. What do you mean by omega? It is known as the angular frequency. It is same as angular velocity. I will also give you the relation. Don't worry. It is known as angular frequency. Do we understand this? We have just written angular frequency of various functions. Yes or no? Okay. What does this T stand
Yes,
for?
sir.
What does this T stand for?
Time period.
No, not time period. Small t stands for the time. What is the time now? In seconds, normally. Omega, angular frequency is in hertz. T is in seconds. Do we remember this?
Yes, sir.
You understand this? Okay. Now let us also go through the terms that we have read. The first term that we have read is VRMS. Yes or no?
Yes,
And
sir.
the RMS value of this voltage will be V naught by root 2. Everyone understands this? We have already gone through this. The average
Yes,
value
sir.
of this V over one cycle would be 0. Do we understand this? Yes or no?
Yes, sir.
Okay. Now let us find the relation between omega, T, and F. F stands for frequency. F stands for frequency. T stands for time period. We are all aware of these terms. T stands for time period. And we know the relation between F and T. Yes or no? F will be equal to 1 by T. Yes or no?
Yes, sir.
Okay. This omega, which is angular frequency, is 2 pi multiplied by F. Remember, this F is frequency. This F is frequency. Yes or no?
Yes, sir.
This 2 pi is nothing but an angle. Yes or no?
Yes, sir.
And hence you can call this omega as angle frequency. They don't call it angle frequency. We call it
Angular frequency.
angular frequency. Do we understand this? So you can write the relation like this. F is equal to 1 by T. That is one relation. Omega is 2 pi F. That is your second relation. And omega is 2 pi by T. That is your third relation. Do we understand all these three relations? Yes or no?
Yes, sir.
I'll give you a minute to win it. Have you noted it down, bacha?
Yes, sir.
Let us again go back. V is equal to V naught sine omega t. Okay, we have understood the meaning of the each and every term. Now, when I take these two terms together, omega t, remember these two terms, frequency is 1 by t, 1 by second, t seconds. So seconds and second will get cancelled, and this will be a dimensionless quantity. Yes or no? This is just a number. This entire thing is just a number. Now, this number, or this will not be a number. In fact, I can call this will be an angle, right? Yes or no? This would be an angle because it is with sign. Sign ke andar whatever is there should be an angle. This is an angle. Now, this angle with different angles, the value of V will change. Yes or no? If I put
Yes,
this
sir.
angle as 0, the answer is 0. If I put this angle as 30 degrees, the answer is V naught by 2. If I put this angle as 45 degrees, it is V naught by root 2. If it is 30 degrees, it is root 3 V naught by 2. Do we understand this? Do we understand this? So instead of calling it as an angle right now, I can also call it as the phase of the voltage. You can call it the phase of the voltage because it tells us what is the value of the voltage, where is the voltage, how much is the voltage. It tells us the value of the voltage. This is known as the phase of the voltage. Do we understand this? This entire thing omega into t is known as the phase. Yes or no?
Yes, sir.
Now I write a different equation. I write the equation of current in this circuit. And I write it like this. I naught sine of omega t plus phi. Again, omega t and phi both are angles. Now, what will be the phase of this current? If I talk about the phase of this current, this entire thing would be the phase of this current. Yes or no? Yes or no?
Yes, sir.
Whatever is inside sign is the phase of this current or phase of this voltage. Yes or no?
Yes, sir.
Now, if I compare the two phases, not the phase, PHASE phase, not FACE phase, are the same. One is omega t, another is omega t plus phi. Are they same? Are they same? They are not same. Yes or no? So I
Sir, the
say
phi is extra.
current and I are not in same phase. Do we understand this? The most important term is they are not in the same phase. Yes or no? Yes or
sir.
no?
Yes,
Okay.
sir.
Now, if they are not in the same phase, you can take it as a race. Phase, race, everything looks similar. They are not in the, if you can take the phase as same, relate to race. Someone will be aage, leading. Someone would be piche, lagging. So phase is just like a race. Phase tells us where you are. So someone would be lagging, someone would be leading. Does you understand this? Someone would be aage, ahead. Someone would be piche, backwards, behind. Yes or no?
Yes, sir.
Now, this is simple common sense. You have V and I. Who is aage? Who is in front? Who is leading? Who is lagging? Tell me. Who is leading? Who is lagging? We have got voltage and current. Who is leading? Who is lagging? Who is leading? Who is lagging? Who is aage? Who is piche? Just common sense.
आगे भी पीछे आई.
This is leading because it is plus 5. So it is leading.
पीछे भी.
And this one is lagging. Do we understand this?
Yes, sir.
So I now can write this like this. Current leads voltage by how much?
Pi.
Phi. Or I can write the same thing in a different way, or voltage
Decreasing by
lag
pi.
current by phi. Do we understand this? Are please tell me that you understand this.
Yes, sir. Yes, sir. Yes, sir.
This phi with which they lead or lag, this phi which they lead or lag is known as,
Phase difference.
yes, that was the entire thing that we wanted to understand. Phase difference. Who is leading, who is lagging? I hope everyone is clear with this. Can I have some raised hands from everyone in the class? That we understand this? Okay. I'll give you a minute, 2 minutes.
Completed, sir.
Completed? Everyone completed?
Yes, sir.
Who is lagging, who is leading, and that is the problem with AC. In DC,
Lagging
they're all
chanting.
together. They're all together. Current is together, voltage is together, all together. But in AC, the problem is,
आपका video lag हो रहा.
but the
आपकी video
current,
lag हो रही.
but in AC, the problem is that, oops,
Your video is lagging.
but in AC,
You also.
the problem is that we have leading and lagging. Do we understand this?
Yes, sir.
You have understood the phase difference, yes or no?
Yes, sir. The leading
Okay.
or
Leading or lagging. Right. Now you'll have to understand and remember this table. Resistance R. If you have resistance R, only the resistance R in a AC circuit. Here we are talking about AC circuits. Remember this?
sir.
We're talking about AC circuits. If it only has resistance R, the phase difference is 0. That means they are in the same phase. Will you remember this?
Yes, sir.
If we have an inductor or L, then voltage leads current by pi by 2. Don't get confused. Don't make it ulta.
Yes,
In
sir.
inductive circuits, voltage is ahead, current is lagging. How much is the angle? Pi by 2. Will you remember this?
Yes, sir.
In a capacitive circuits, voltage lags current by pi by 2. Will you remember this?
Yes, sir.
Please note it down. I'll give you a minute to note it down.
Completed, sir.
Everyone
Yes, sir.
completed this?
Yes, sir.
Just give me a minute. I will just get this screen on because everything is not there in the sheet, and that is why I have to get this. You can see the screen, right? You can see the screen, right? Okay. Is everyone there?
Sir.
Okay. Now, we have three elements here. We have R, we have L, and we have C. R standing for resistance, L standing for inductance, and C stands for capacitance. Now, every resistor has every resistor has a resistance, yes or no? And we denote it by the letter R. The SI unit is ohm. Remember this? Every inductor has an inductance, yes or no?
Yes, sir.
denoted by L. Henry, 1 Henry, 5 Henry, 10 Henry. Every capacitor has a capacitance. We denote it by C. Yes or no?
Yes, sir.
Now, if we talk about in DC circuits, DC circuit, it has a resistance R, it has an inductance L, and it has a capacitance C. I should have written here resistor. So let me change it so that you don't get confused why I've written it 2 times. So this is resistance, this is inductance or inductor, and this is capacitor. Do we understand what I'm writing here?
Inductance, capacitor.
Yes.
Yes,
Resistance
sir.
is R, inductance is L, capacitance is C. Now in AC, when we talk about this AC circuits, now resistance is still R. The resistance of the resistor is still R. Now this inductor or capacitor also behaves like resistor. This inductor or capacitor, are you noting my words? This inductor or capacitor also behaves like inductor or capacitor also behaves like
Yes, sir.
resistor. And how do I find the resistance? We find it by multiplying omega with L. Now this omega into L, I can say that to understand, this is the resistance
Omega L resistance.
of the inductor. This is the resistance of the inductor. Do we understand this?
Yes, sir.
But it does not look good to call it resistance of the inductor. Instead of calling it as the resistance of the inductor, we call it by a different name, and the name is inductive reactance. Inductive reactance. Am I clear?
Yes, sir.
This, if you multiply omega with L, it will give you the resistance of the inductor in AC circuit.
Sir, your video is lagging.
But
Sir, your network is not well.
we write it as inductive reactance. Am I clear?
Sir.
Please note
Sir.
it down what you see. I understand you have told me. I know that. Please note down what I'm telling you. Okay.
Audio also, sir, lagging.
You can see the screen. Yes. Don't look at
Yes,
my
sir.
face. I will take off my face. Face is gone. You look at the video. You can see the video, right?
Yes, sir.
Yes.
Completed,
So,
sir.
so omega L is the resistance of the inductor. We can call it inductive reactance.
Reactance.
Now, similarly, I can find the resistance of the capacitor, and it is given by 1 by omega C. I can write this 1 by omega C as resistance of capacitor. 1 by omega C will be resistance of the capacitor. This is not a good name. So what name should I give it?
Sir,
Common sense.
capacitance reactance.
We call it capacitive reactance. Do we understand this? Yes or no?
Yes, sir. Sir, video lagging, sir.
The SI unit is ohm. Don't worry, it will come. The SI unit of all these 3 things are ohm. Do we remember this? Do we understand this?
Yes, sir.
Note it down. I'll give you time.
Completed, sir.
Everyone got this?
Yes, sir.
Okay. So, do you understand the difference between AC and DC?
Yes, sir.
In AC, in DC, we had what? We had resistance
Resistance, inductance,
and
capacitance,
capacitance. Here we have resistance,
induction,
inductive
reactance,
and
capacitance, reactance.
capacitive reactance. Well done. Now I will.
All SI unit are ohm.
All SI units are ohm. Good, good, good. Now,
Thank you, sir.
well done, sir. So now again, I will show you in good table the same thing. Do you see this, bacha?
Yes, sir.
We have a pure resistor. In a pure resistance, resistor phase difference is 0. Yes or no?
Yes, sir.
Voltage and current are in the same phase. Yes or no?
Yes, sir.
Now, there is something known as this Z. We'll understand this Z in the next class. The resistance is R. Do we understand this?
Yes, sir.
Then we have something known as the phasor diagram. This phasor diagram tells us which thing is where. Here you can see current and V. They are both together because they are in the.
Same phase.
Do we understand this? Can I have some raised hands from everyone? Girls? They are in the same phase. Now let us move on, and this is the table that you will draw because it is not in your sheet. Now we move on to pure inductor. Phase difference is pi by 2. Do we understand this?
Yes, sir. Leads.
Who leads? Not leads. Who leads? Who is aage? Who is piche?
I leads.
Again, you have become Gajini. So that is not going to help you out, beta. I can't repeat
Yes,
the
sir.
same thing
Voltage
10,000
is
times.
leading.
Yes, you have to remember this voltage. Remember,
Voltage is leading.
when a doctor is writing prescription, he does not open notebooks and internet and finds out the name of the medicine. Does he do that?
No, sir.
Because if I have to find it from the internet, I can do it on my own. Yes or no? Why do I need a doctor?
Yes, sir.
Google can be a doctor. Okay. Now this inductive reactance, which was omega L, instead of writing it as omega L, I can also write it as XL. X standing for reactance, L standing for inductive.
Inductance, reactance.
Inductive reactance. Do we understand this?
Yes, sir.
Now this is how it is represented, and it is shown smaller. Current is here, current is
Pi
piche,
by 2 angle.
pi by 2 angle, voltage is aage. Do we understand this?
Yes, sir.
Move on to pure capacitor. Again, the phase difference is pi by 2. But who is leading? Who is lagging?
Lagging VC.
Voltage is
lagging.
lagging. XC is capacitive reactance, and we find it by finding 1 by omega C. Yes or no?
Yes, sir.
And you can see the phasor diagram. Current is here. Where is voltage?
Yes, sir.
Voltage is piche. It is lagging. Do we understand this?
Yes, sir.
You will have to draw this diagram, bacha.
Completed, sir.
Completed, sir? Shall I move ahead, sir?
Yes, sir.
And, sir, this is the first question, sir. I hope you can see it, sir. Can you tell me the answer, sir?
The 1 minute, sir.
Yes, beta. Take your time. But do you have confidence that you will be able to do it, beta?
Uh,
Yes or no? No or yes?
Yes, sir. Yes, sir. Wait, sir.
Yes, sir. Okay, sir. Shall I help you, sir? So, initially the value is x.
By 2, sir.
This x will be equal to 1 by omega c. Yes or no?
Answer x by 2.
Now, let me call the new x as x dash. It becomes 1 by new omega. Frequency will become double. So what will happen to omega? Will it become double or will it remain same? Frequency in omega. Omega is 2 pi into f. Do we remember this? So the new angular frequency will also become 2 omega. Yes or no?
Yes, sir.
Capacitance is also doubled. So new capacitance becomes 2c times. Yes or no?
Yes, sir.
What is the answer, beta?
X by 4.
The answer is x by 4. Can I have raised hands from everyone in the class that we understand this? So see, simple questions come in the examination hall. If you have faith in your ability, you would be able to solve it. So from now, whenever you go back to your hostels, you will be starting to do this exercise. You will not be able to do all the questions, but whatever portion we have covered, you should be able to do this. Yes or no?
Yes, sir.
This one, sir. एम्स में जाना है सर, तो दिस वन क्वेश्चन सर.
Answer A, sir.
In a AC circuit containing only capacitor, current
Leads by pi by 2.
current leads the voltage by pi by 2. That is the correct answer. Well done. So we
Answer
understand
A.
how questions are made, how simple questions are.
Yes, sir.
Yes or no?
Yes, sir.
Okay, let me see if there is any more question that I can do at this point in time. We have not discussed power. We have not discussed power. Okay, this one will be the last question, and I hope you can try the rest of these. Find out question that you can do at this point in time. In a pure inductance, the current is
Leading potential by pi by 2.
Arey yaar. I will never come to you people to get myself checked because you all are Ghazni. You will give me the goli for Zukham when I am having Bukhar. I just can't trust you guys. You are all Ghazni. You are worse than me. Pure inductive circuit, current is leading or current is lagging?
Pure induction.
Huh?
Current is lagging.
Current is lagging and you are telling me leading, so you will give me the medicine for fever when I have cold, and I will suffer more, and then I'll never come to your hospital again because I will lose all my faith in your abilities. Do you want that to happen?
No, sir.
No, sir. Then what do, sir? You don't become Gajini, sir.
Yes, sir.
Yes, sir. Last question, sir. What is the answer, sir?
Sir, C.
1 by root 2 times of peak value. That is correct.
Yes, sir.
As you can see, this same question has come multiple times. This again, it came in this year, MPPT, then
Answer
it,
C.
yeah, see, same question here. Now, similar question here. Can you give me the answer? That will be the last question for today. 55. Inductive circuit. Current is I is equal to I naught sin omega t. What will be the voltage? Waiting for your answers, bacha. Don't become
Answer-
Gaznis.
Answer A.
Answer is A. That is correct. Well done. So at least you are getting better than Mr. Ghazni, and that is good.
Yes,
Well,
sir.
on that note, I will leave this entire exercise for you. You have to pick and choose. You understand the meaning of pick and choose?
Yes, sir.
We have not done the entire chapter. We only have covered one part of it. In the next class, probably you will be able to solve almost all of these. So we'll have to wait till the next class. Till the next class, you solve as many questions as there are. I think there are around 146 questions in this section. Even if you can solve even 50 of those, it is good enough for you to do any question that comes in the examination hall. Anyone having any doubt on this class today?
No, sir.
No, sir. Then we'll wind up this class today here. And I'll see you in the next class. In the next class, we will try to wind off this AC as soon as possible, or maybe in the next to next class. So I'll see you there. I hope all of you stay good. Take care and have a nice day, bacha.
Take care, sir. Bye, sir.
Bye, sir.
Love you, sir.
Me too, sir. Always, sir.